is bonding material. Bonding material. Bond material commonly used are vitrified clay. So this is called vitrified clay because the clay material is used and it is done by very high temperature. Clay is placed on the oven and heating up at some elevated temperature. Then the grain particles is called in that after that the grain particle is formed. This grain particle is called vitrified grain. Okay, another one is resinoid resinoid material, silicate, rubber, shellac, and metals also. Okay, now vitrified clay is very hard material, hard and strong, rigid. Vitrified material is very hard, strong, and rigid type material. Is mostly used for vitrified clay used for bonding material. Mostly used for bonding material. Okay. Now silicates. Silicate bonds are essentially used for actually soda. Silicate bonds are essentially the silicates of soda. Actually, it is made of soda. Silicate of soda, or another name is glass. Water glass. Okay, this material this material are not as strong enough as the vitrified bond. The grains of the silicate material are dislocated more rapidly. Silicate material grains are dislodged or breaking from the wheel is more rapidly. As a result, the operation is if we use silicate as a bonding material, so the wheel is rapidly worn out. Okay, so because the temperature during grinding, the temperature is very high, so silicate bonding material is easily uh, dislodged from the uh, wheel. So if the process is in cooling condition or cooler condition or lower temperature grinding, so that we have to use silicate material, okay, as a bonding material. Now rubber rubber is a used for bond rubber is used as a bonding material for flexibility. Okay, now shellac bond. Now first of all we remove this. Now shellac bond are used making the thin and strong wheel possessing some elasticity. Okay, because now the what is the characteristic? Shellac bond is very strong wheel. strong bonding material, but used to making thin wheel. Thin wheel. The thickness of the wheel is very thin because it has some elasticity. Okay, for smooth finishing, smooth finishing on hard surface, we have to use shellac type of bond. Shellac bonded wheel used in grinding, such as camshaft and mill roll. Okay, used to grind the camshaft and milled roll. Okay, now fourth part is structure. Structure. Since the grinding wheel is a similar to milling cutter, okay, with very large number of randomly oriented teeth, it must have some void areas because I already told in our earlier lecture the grinding wheel look like this. Okay, so there are some void areas between two teeth or two abrasives. There are some void areas. Okay, why this void area is used? Because if the material removed in the form of chips, then it has to be flow over the wheel. So there are some requirement of space, so that if the chip is material is removed in the form of chips, then chip is flowing in the this void areas or gap areas over the wheel. That is why the space is provided. Hmm. Now, if the space is very small, the gap between the abrasive is very small, then chip does not flow properly, so that chip is stayed in that void areas, so that blocking the passage. Hmm. This is called loading. Loading of wheel. If the space is small, then the chip does not flow properly, so chip stay in that gap, so that all the gap is filling with the chip, so the wheel is fully loaded. It does not work properly, so that is called loading of the wheel. Okay, loading leads to inefficient cutting. Inefficient cutting. Okay, now if the void area is too large, if the void area is too large, again the cutting is called inefficient cutting. Why? Because at a time when we cut the job, at a time number of teeth are in contact with the job is less, so the cutting time is larger, because at a time the number of teeth are in contact with the job is less. But if the space is small, then number of contact teeth on the job is very high, so that if number of teeth are in contact with the job is less, so the cutting time is requirement is very high. So material removal rate is very low. Okay, that is why it is called inefficient cutting. So